Thank you very much for attention. This is an Urchin Tower in Japan. Okay. This is the commercial sea urchins in Japan. Strongylocentrotus nudus, intermedius. Northern species are most important in Japan. And the other 4 species are also eaten by the local people. Okay. And please remember the oceanographic structure in Japan. Kuroshio warm current and the derivative Tsushima warm current is here. And only the Hokkaido, East Hokkaido and Tohoku area, I mean the northern east of Honshu are washed by the Oyashi, the cold current. Okay. And this is another map showing the grazing by sea urchins in Japan. The dark blue shows the urchin barrens caused by each species, and light blue shows only the distribution. The Strongylocentrotus nudus are the problematic in the northern Japan, and in southern Japan, Heliosidaris and the diadema species are the causative. We can see some factors affecting the population of sea urchins: salinity, wave, sedimentation, and water temperature. Okay. And this is an example for the seawater temperature also rising around the coast of Japan. So this showing the data from the meteorological agency. The high rising rate in the Sea of Japan coast and the southern Japan, but not in the OSCO coast so much. Okay. And these are the many events or episodes of sea urchins in Japan in relation to these 4 factors: salinity, sedimentation, wave, and water temperature. And we have a long trend, 3 long trends. I mean the expansion of the species. For example, the increase of diadema in southern Japan and the expansion of Hemicentrotus pulcherimus since 1990s in northern Japan, and also the increase of Strongylocentrotus nudus in northern Japan. These are said to be the long and gradual trend in Japan. Other things are event in the short time, temporary event. And in the dark frame, the mass mortality of Strongylocentrotus nudus or tsunami at the Great East Japan earthquake is the recent, and which I concerned so much. Okay. This is showing the distribution of Strongylocentrotus nudus and its mortality in summer of 1994. In Japan, this is the first event reported from the country. So reported by myself. And in the red colored areas, so I mean the southern part of its distribution, in the warm water season, Strongylocentrotus nudus died. This is the Toyama Bay, and before I came to Tokyo, I have worked here during 1989 and 2001, and noticed this event. This is the circle showing the distribution, and the cross showing the mass mortality in 1994. Please remember that this bay is small but very deep at the center, 1,000 meter, more than 1,000 meter. Okay? And Strongylocatus nudus died at America. There is stone piles, the 50 meter and 100 meter, the artificial stone piles. That was built to expand the gelidium beds for the fishermen. But when I worked there, I was monitored the invertebrate densities there. And then I have noticed in 1994 that in summer, July, nudus died like this and through the bold urchin stages. Okay? And the gonad indices and feeding as a stomach contents were followed before 4 years. 4 years. And then the indices stopped because they died. Okay? So this was a very lucky monitoring. And this is the density of many invertebrates. I mean the turbo, so the gastropod, and the stichops, so the sea cucumber and the nudus, and 2 species of sea star. Only Strongylocatus nudus died during this period, and for 3 years, nudus was at low level after the mass mortality, but then recovered like this. Okay. At Himi, on the opposite side of the Toyama Bay, nudus died, and there, after the mass mortality, the algal beds recovered, like this. Seaweed come back. But after that, because of high sedimentation, the algae are removed. So now, again, this is barren ground. Okay. At Himi, there was a good water temperature monitored. And here, in 1994, there was a highest record of the seawater temperature, more than 30 degrees. Okay? This high temperature killed the northern species, Strongylocatus nudus, here. But in some places, they could survive because of refuges, the presence of refuge. At Wozu, there is a good submarine groundwater seepage. So the underground fresh water is spring. So there is they chilled the bottom layer, so they could survive like this. And in one more, the Kurobe, at this place, this is a steep slope. So if you go from shore to 100 meters, the depth go down to 30 meters. Then the nudus could survive by burrowing below the pebbles and something like this, and escaping in the deeper end of the stone beds. So they never died off. Okay. In another case, for the southern species, this is the upload of the distribution in diadema in Japan. Not this is the third species, but not this diadema, but Daisuke. As I told you before, many people believe that the recent increase of diadema is from the global warming or so, but historical record shows much more northern limit of distribution. And you know, we have a good record as 1898 in around Tokyo. Tokyo is here, and Yokohama, where I lived, is here. My fields are there. But in these places, the presence of diadema has been recorded for more than 100 years. And also on the Sea of Japan coast, historical record was here. But these areas are very unstable, so the fluctuation, so sometimes presence, sometimes absence, okay? But here it was, I found the old record in 1811. So this seems to be within the fluctuations in the good historical record, okay? But for the southern species, mass mortality occurred in the cold winter, sometimes at low water temperature below 12 degrees of centigrade. This was reported here. Many places, probably it might occur, but no record, because diadema is not a commercial species and very few people paid attention, okay? But here, this has a record. And this also has a very interesting report. It is very important. In the, just a moment, here, on the Sea of Japan coast, Wakasa Bay, here, this is Kyoto, near the Kyoto. After stopping nuclear power plant, I mean stopping the release of warm waste, diadema died off at Takahama in Wakasa Bay because of loss of warm waste water. Delta T was 2 degrees. 2 degrees were higher, by 2 degrees higher around the outlet of the warm waste. This was in the newspaper in Japan. Very famous record, in very recent one here. Because, you know, Japan was attacked by the big disaster, East Japan earthquake. So many nuclear power plant has stopped to check more and more. Then the power plant stopped, and they changed the ecology or of these warm water species. Okay. Sometimes we have experienced the low salinity water. I mean the flood. And all staff of Hokkaido Prefectural Station reported the mass mortality of intermediates around here. There was very good rainfall every year, and he noticed the stranding of intermediates within half a day after the rainfall. And then he had a small experiment that the exposure to each low salinity water for 6 hours. So more than 10% the species can tolerate the low salinity water for 6 hours. The very good low salinity tolerant species, but sometimes they die because of the flood. This example only mentioned about the salinity, but low salinity in flood sometimes are accompanied with high sedimentation or high turbidity. Another example introduced by myself, this is Toyama Bay, and this is Newzen town. And this is, we have a Kurobe River here, and at the upstreams, so many dams have been constructed. And in one dam, the sedimentations accumulated in the dam, so they have to release. So then they released 1,000 tons of turbid waters, fresh waters, with the, sedimentation. So the beautiful, before there was a beautiful sandy seaweed community, including the Geridium or, I forgot the scientific name, but beautiful red algae, okay? But here, after the release of the sedimentation, the community were covered with the mud, and very slimy ones, and this is myself, and so 25 centimeters of mud were accumulated in the concave on the bottoms. Okay. So on the sedimentation, many animals have died or buried in the sedimentation. Abalone, turbo, and sea urchins also like this. Okay, so not only the low salinity water, but sedimentation are coupled with this phenomenon, I believe. And this is another case. The typhoon is very popular from summer to autumn. And sometimes the sea urchins are crushed in the bottoms. And this was the example appeared in some blogs in the internet. And another example, in the southern coast, Heliosidalis crassispina were also damaged by the attack of typhoon periodically like this. Another people reported. And the last one I'd like to introduce is the tsunami. And you know, this is the northeast Japan, often attacked by tsunami because of the Rias coast. I mean some coast like a Garcia in Spain, and very narrow, small bays. There are so many bays. Yeah? So good effects, and the tsunami are very famous and popular around this area. But in Okshiri Island, this was the first experience for the echinoderm biologist paid attention. And you know, this tower was built after the tsunami in small island in Okshiri. Okay? There was a large stranding of sea urchins because they were pulled down with a strong wave. Okay? Now, the Okshiri Islands are recovered as this. The largest one was the Great Eastern Japan earthquake. Magnitude was large as 9. And many people died, and I was safe. I dove only 1 week ago at this small bay, but I was very lucky to, yeah. You know, the beautiful modern towns are destroyed as this. And the various traits after the earthquake of tsunami, okay? Subsidence and garbage, you know, crush of rock, or increased turbidity, and so many effects This is the turbid water here. And in the town, breakwaters, very large breakwaters are pulled down by the strong wave and no breakwater now. Then the sea urchin populations were crushed or withdrawn into deeper or offshore areas, and kelp beds recovered in the inner parts. Around this place, kelp beds recovered. But in outer coast, the gathered noodles remained or grazed seaweed near the mouth of areas like this, because boats of fishermen are lost, so they stopped harvesting. So they begin to graze. Okay. So many patterns. And in other places, baby boom occurred after 1 year and a half, 1.5 years, like this. Small sea urchins occurred. But since climate change process predict increasing extreme conditions rather than a simple elevation of seawater temperature, all of the above processes should be considered to forecast the expansion of urchin barrens, including the long-term trend and the episodic events, so many small events. But in Japan, there are many, many changes in the coastal areas. I will not read now because of short of time, but the increase of concrete blocks and aquaculture and change of river mouth, and so many things are changed. Okay? Thank you very much.